Alright, in this video here we are going to talk about the change of base formula, which is a formula that we can use to take a logarithm from whatever base that we're given and change it into really any base that we want to change it to. Right? And we use this change of base formula usually when we need to evaluate a logarithm. Most calculators don't allow you to type in weird bases for logs, like if I had, what's log base 2 of 17? Well, my calculator doesn't allow me to type in log base 2. My calculator only has buttons for the common logarithm with base 10 and the natural logarithm with base e. Right? Those are the only two logs that my calculator will do. And so if I have a log in another base, but I need to figure out what it's equal to, well, then I can use this change of base formula and change that log base 2 into a base 10 or a base e, a log or an ln, and then use my calculator to figure it out. Right now, there are some calculators out there that have come out in recent years that do allow you to type in a log with whatever base that you want to put it into. So when we get to the point of this where I do an example, I'll show you like where, if you have like a TI-83 or 84 like my calculator, I'll show you where you can find that if you have it. And if you have that, then you can use that and not use this change of base formula. But if you don't have that feature on your calculator, then you need to use this change of base formula in order to evaluate logarithms. All right, so what the change of base formula says: if I have log base b of x, all right, so I have a logarithm with a base b, but I don't like base b because, like I said, if it's a log base 2 of 17, if x is 17, well, I don't know how to calculate that unless I have a calculator, right? So I need to change it to some other base. So the change of base formula says, well, I can change that into log base a of x over log base a of b, where that base a can be any base for a logarithm, any valid base for a logarithm, which, remember, logarithmic bases have to be positive numbers other than 1. All right, so I can change that base b, whatever I'm given, into any other positive number other than 1. Right, so I can change a base 2 into a base 5. I can change a base 3 into a base 17. Now, usually I don't change things to base 5 or base 17 because my calculator still doesn't do base 5 or base 17. Right, so normally what we do is we take that log base b of x and I change it into one of these two down here. Either log of x over log of b, right, where I'm using the common logarithm with base 10, which every scientific or graphing calculator has that common log button, or I change it into the natural logarithm with base e, ln of x over ln of b. And again, any scientific or graphing calculator has an ln button, so you can take a logarithm from whatever base you're given and change it to either the common or the natural log. Either one will give you the same result when you go ahead and type this new expression into the calculator. All right, so the key thing when you're using the change of base formula is just making sure you're taking these two values here, the b and the x, and just putting each one in the right spot. Right, one goes in the numerator of the fraction, the other goes in the denominator of the fraction. The way I remember it, it's kind of a simplistic way, but it totally works. The base number, the b, well, that goes down to the bottom, the basement, right? So the base goes down to the basement. So that b, that base number, always goes down in that denominator of the fraction you create. And the other number, the x, is the one that always then ends up in the numerator. All right, so the base goes downward to the basement, to the bottom. I'll start with the letter b, makes it easy to remember. All right, so the base goes down to the bottom, and then the other one stays at the top. All right, so that's what the change of base formula looks like. So I'm going to pause the recording here and erase these formulas and put up just a couple examples where we'll use the change of base formula to actually calculate or evaluate logarithmic expressions. And I'll show you, on the calculator where you can find that log base command if you are, if you have it on your calculator. And then if I have time at the end of the video, I'll also show you why this formula works, right? Kind of show you a proof of this formula. It's kind of a cool thing to see, well, why does this equal that? Like, it seems like a weird thing that I just write that up there. But there is a reason for it, and like I said, if I have time, I'll explain that to you at the end of this video too. Alright, so we got a couple examples up here. We want to evaluate log base 8 of 5 and log base 9 of 20. Now, if you looked at some of the other videos that I've done on logarithms, we did do some examples where we evaluated logarithms without having to use our calculator. But that only works if the numbers fit together just right? Remember what a logarithm represents. I have a base 8. I have to raise that 8 to some power to give me 5. Well, I don't really know what power to raise 8 to give me 5. If this was like a 64 here instead of a 5, well, then that's 8 to the second power. So log base 8 of 64 would equal 2, right? Because 8 to the second power equals 64. But I don't know what power to put on the 8 to make it equal 5. It's going to be a really weird number, right? So in cases like this where we're like log base 9 of 20, I don't know what power to put on 9 to make it equal 20. Like I just don't know what to use there, right? So in cases like that where the numbers don't fit together and you're not able to figure out what the exponent is just based on the numbers you have, then you have to use your calculator to get the value of the logarithm, which means in most cases using the change of base formula. Right, so if I have log base 8 of 5, I want to change that to a base that I can use in my calculator. So let's change it to the common logarithm. Right, so I'm going to change it to common logarithm. So the key thing here is making sure you put the same log, the same base on the top and bottom. Don't put a log up here and an ln down there. That'll screw everything up. Right, they're either both log with base 10 or they're both ln with base e. Right, the top and bottom have to be the same. Right, and then remember the base number goes down to the bottom. Right, so the 8 is going to go down here, and the other number, the 5, is going to go up here. So log base 8 of 5 is going to equal log of 5 divided by log of 8. And once I got that set up, let me go to my calculator. Remember, on the graphing calculators, the TI-83s and 84s, the log and the ln button are over here on the side next to the 7 and the 4. So I do log, and let me actually look at this so I can type it correctly. Log 5, close parentheses, divided by log of 8. Right, you got to make sure you close the parentheses after that log of 5 so that the calculator knows that it's going to calculate the log of 5, and then after it gets that, divide it by the log of 8. Right, and when I hit enter there, I get 0.77397 and so on. Right, so that's my answer here. All right, so this equals, let me see what that was again, 0.773976, let's say. All right, and for a lot of these, logarithm, like evaluating logarithms, for a lot of them, you end up with irrational numbers, right? Very few times does it come out to a nice number like 2 or 3. If it came out to 2 or 3, you would be able to do it by hand. If 5, like I said before, if this was like a 64 instead of a 5, that's going to equal 2, right? But if this number here is not a nice clean power of 8, you're going to get an irrational number, which means you have to round it off after a certain number of decimal places. In this case, I included 6 decimal places. Right, so remember what this means. If I take 8 and I raise it to the power 0.773976, that's going to give me 5. Right, so 8 raised to this power gives me 5. That's what a logarithm represents. Right, so that works fine when I change it to a common log, but what if instead of the common log I chose the natural log? Right, what if I made this ln of 5 divided by ln of 8? Right, would that give me the same result? Well, it should, because the formula says that I can change a base 8 into whatever base I want. Right, so I can change it to the log, or I can change it to the natural log, ln. Right, so I do ln of 5 divided by ln of 8, and if I hit enter, I get the same result, 0.773976, and so on. Right, so it doesn't matter which one of those you change it to, the log or the natural log. So my advice is just pick one, whichever one you're more comfortable with. Just use that one every time. Right, it doesn't matter. Always comes out the same. All right, so that's how we can evaluate a logarithm with numbers that don't fit together very well by using this change of base formula. Right, it's a very powerful formula because it allows us to take the log of whatever weird base we have and make it one that we can put in our calculators. Right now, like I said before, some calculators, especially like the TI-84s, some versions of the TI-84 have what's called a logBase function, which let me write that up here. I believe it's like this, where the log is lowercase and the base is all capital. I could be wrong about that as far as what letters are capital and which ones are lowercase, but it's definitely called logBase, right? And to find that, to see if your calculator has that, I don't think TI-83s have it, and some of the TI-84s do. See, I have a TI-84, but I don't have that, and I'll show you where you can find it, though. So if you hit that math button to get to the math menu, which is below the second and the alpha keys, so if you hit the math menu, and then the very first menu on the left there, the one that says math, if you just scroll all the way down that menu, right, you see there's a whole bunch of different things that are in there, and you get to choice 0. Now mine, if I go past 0, it takes me back to the top, right? But if you keep scrolling down past 0 and you have like choices A and B after that, one of those two, it's either A and B, I forget which one it is because like I said, I don't have it on my calculator. One of those says logBase, right? So if you keep scrolling down there and you see something that says logBase, choose that. And then it'll bring up on your main screen, it'll say logBase, or it'll say log, or I forget exactly what it looks like, but it'll give you like a little box to put the base, and it'll give you another box to put the number. So all you have to do is when it brings that up on your main screen, type the 8 in that box and type the 5 in that box and hit enter, and it's going to give you this number. right? So if you have that function on your calculator, then you don't have to use this change of base formula in order to evaluate a logarithm like this. You can just use that logBase function and it'll do it for you. Right? If you have a TI-89 calculator, there's also a way to do that in the TI-89 calculator. I do not have a TI-89, but I've had students before who had one, and they asked me if I could do it, and I figured it out. There's a way to do it. I think I just looked it up online. So if you have a TI-89, there's definitely a way on that calculator to type in a logBase A to 5. So my advice is just maybe search for it online. How do I do a log with a different base in the calculator, and it'll show you how to do it. All right. But if you don't have those features or those types of calculators, this is what you have to do to evaluate this kind of logarithm. All right, the next one here, logBase 9 of 20. All right, well, I can't do logBase 9 of 20 because I don't know 9 raised to what power is going to give me 20. It's going to be 1 point something, right? Because I know 9 to the first power is 9. I know 9 to the second power is 81. And 20 is in between 9 and 81. So it's going to be 1 point something, but I don't know anything beyond that. Right, so I can change this to log of 20 over log of 9. All right, again, the base number goes down to the bottom, the other number goes to the top. Make these either both log or both ln. It doesn't matter which one you want to use. So if I do log 20 close parentheses divided by log of 9, that gives me 1.3. I'm trying to type and read a number at the same time. That does not work very well. All right, I get 1.3634, and I did it on my calculator twice, one with the log and one with the natural log. Once again, just to show that it gives us the same number each time. All right, so then I almost dropped my calculator on the floor. So this gives me 1.3634, let's say. I'll round it to 4 decimal places there. All right, so that's telling me that if I do 9 to this power, it's going to give me 20. All right, so that's using the change of base formula to evaluate logarithms. It's a very powerful formula because it allows us to evaluate any logarithm, no matter what the base is, no matter what that number is, no matter how weird they are as far as fitting together with exponents. We can always use this change of base formula to figure that out. All right, so it allows us to evaluate any logarithm. All right, what I'm going to do now, because I have a few minutes left before I run out of time on this video, I'm going to erase this and just real quick put up a proof of why the change of base formula works. So if you're interested in the reasons why things are what they are, you might want to stick around and watch the rest of this video. All right, real quick here in the last couple minutes of this video, I'm going to explain why this change of base formula works. Right, so logBase b of x, right? Remember, the change of base formula is logBase b of x equals logBase a of x over logBase a of b. So I start with logBase b of x, and I don't know what that's equal to, so I just make it equal to something. Let's say it equals y. Right, it has to equal something, so I'll just put a variable there and call it y. What I do then is I change that into exponential form, right? So I did a video about switching between exponential and logarithmic form. The base b to the y power equals x, right? So these two equations are equivalent. The first one's in logarithmic form, the second one's in exponential form. So b to the y equals x. Now that I've got that, I take another logarithm on both sides of the equation. So I do logBase a on both sides, right? So I have logBase a of b to the y power equals logBase a of x. Right, I can do a logarithm on both sides of the equation as long as those logs have the same base. Right, and that's why when we do the change of base formula, we can change it to any base we want, because at this point here, I could put any base on both sides. I could put just a logBase 10 on both sides. I could put the natural log on both sides with base e. Right, that logBase a, that a could be any positive number other than 1. Right, so once I do that, I put that logBase a on both sides. Then, since I have logBase a of b to the y power, I can use the law of exponents, which again, I did a video on the laws of exponents. If I have a log of something to a power, I can bring that exponent out to the front. So that's y times logBase a of b equals logBase a of x. And then, to get this y by itself, if I divide this logBase a of b to the other side, I get y equals logBase a of x over logBase a of b. But remember, y up here is equal to logBase b of x. Right, so logBase b of x equals y, but y equals logBase a of x over logBase a of b, which means the logBase b of x directly equals logBase a of x over logBase a of b, and there's our change of base formula. Right, so again, a fairly simple proof as far as mathematical proofs go to show you that this formula is true. Right, so if you're like me, you like to see why things are true, not just take, I'm just a guy on a video saying, hey, this is a formula you need to know. People didn't just make up these formulas. They are proven to be true, which is true of everything in mathematics, right? So if you like that kind of thing, you might want to think about pursuing like a major or a minor in mathematics, because when you get to higher levels of math, this is the type of stuff you do, all those formulas that you learned along the way, seeing why they're true.